Hey there! How's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. Picture this. It's October 23rd, 2023. Most of the world is asleep, but on the summit of Haleakala in Hawaii, something extraordinary is about to happen. Something that will change everything we thought we knew about our place in the universe. In just a few hours, a routine night of scanning the sky for dangerous asteroids will turn into the most important discovery in human history. And the person who makes this discovery, she's not even supposed to be there. Before we continue this journey, tell us where you're tuning in from. And if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Sarah Chen sits alone in the control room of the Atlas Telescope facility, her coffee growing cold as data streams across multiple monitors. The Atlas system, that's the Asteroid Terrestrial Impact Last Alert System, was built for one purpose: to protect Earth from incoming space rocks that could wipe out cities, or worse. It's essentially humanity's early warning system, scanning the sky every single night, looking for anything that might be heading our way. Sarah wasn't supposed to be working this shift. She'd volunteered to cover for her colleague James, whose 6-year-old daughter had come down with the flu. So here she is at 2:30 in the morning, watching the automated systems do their job, flagging objects that might pose a threat to Earth. It's routine work most nights. The AI identifies dozens of objects. Sarah checks the data, confirms they're just regular asteroids or comets, and files the reports. Rinse and repeat, but tonight is different. At exactly 2:47 a.m. Hawaiian time, the system flags something unusual. Object designation /2023 UX1. The automated analysis shows standard parameters at first glance. It's roughly the size of a football field, maybe 300 feet across. Nothing remarkable there. Asteroids this size zip past Earth all the time. Then Sarah notices the velocity vector. She blinks hard, thinking her tired eyes are playing tricks on her. She runs the calculation again, then a third time. Each time, the computer spits out the same impossible number, 58,000 miles per hour. Now here's why that number made Sarah's blood run cold. Objects in our solar system follow predictable patterns. Comets from the outer reaches might hit 30,000 miles per hour as they swing around the sun. Asteroids from the asteroid belt typically cruise at around 15 to 20,000 miles per hour relative to Earth. But 58,000. That's not just fast, that's escape velocity fast. That's this thing came from somewhere else fast. Sarah's hands are actually shaking as she pulls up the trajectory analysis. The direction vector shows this object isn't coming from anywhere in our solar system. It's not coming from the asteroid belt between Mars and Jupiter. It's not coming from the Kuiper belt beyond Neptune. It's coming from the direction of the constellation Lyra from interstellar space. This thing traveled here from another star system. She reaches for her phone to call her supervisor, then stops. What if she's wrong? What if there's an error in the system? She's about to wake up Dr. James Patterson, the facility director, at 3 in the morning, with news that will either make history or make her look completely incompetent. So she checks everything again. The telescope's calibration perfect. The tracking data consistent across multiple observations. The velocity calculation. She runs it by hand this time, using basic physics equations. The answer doesn't change. This object is moving too fast to be from our neighborhood of space. But here's where it gets really strange. As Sarah watches the data stream in real time, she notices something that makes absolutely no sense. The object is accelerating, not dramatically but measurably. And it's doing this without showing any signs of outgassing. No comet tail, no visible jets of material being expelled that would explain the acceleration. When comets get close to the sun, they heat up and start ejecting gas and dust, which creates that beautiful tail we see in pictures. This ejection of material pushes back on the comet, causing it to accelerate or change direction slightly. It's basic physics, Newton's third law. For every action, there's an equal and opposite reaction. But this object, It's accelerating with no visible means of propulsion. It's like watching a car speed up with no engine running. Sarah finally makes the call. Dr. Patterson answers on the fifth ring, his voice thick with sleep. Sarah, what's wrong? Is the system down? James, I need you to look at something. Object A2023UX1. Can you access the data from home? There's a pause, some typing, then a very long silence. Sarah, check your calculations. I have. 5 times! Another pause. I'm coming in. Within 30 minutes, Dr. Patterson is standing behind Sarah's workstation, his hair uncombed, still wearing the MIT t-shirt he'd slept in. They run through the data together, checking and double-checking every measurement. By 4:30 a.m., they've confirmed what Sarah discovered. They're looking at something that shouldn't exist. At 5 a.m. Hawaiian time, 11 a.m. on the East Coast, Dr. Patterson places a call to the International Astronomical Union's MINA Planet Center in Cambridge, Massachusetts. This is the organization responsible for coordinating asteroid and comet discoveries worldwide. Within an hour, observatories in California, Chile, South Africa, and Australia receive urgent requests to point their telescopes at specific coordinates in the sky. By noon, the confirmation comes in from Palomar Observatory in California, then from the Very Large Telescope in Chile's Atacama Desert, then from the South African Astronomical Observatory. Every telescope that looks at this object sees the same thing, an interstellar visitor moving at impossible speeds. But here's what makes this discovery truly extraordinary, and what the public won't learn for several more days. As more observatories join the observation campaign, they discover that this object isn't just fast and mysterious. It's doing something that defies every model of natural celestial mechanics. The object rotates exactly every 7 hours and 18 minutes. Not approximately, not roughly, exactly to the second. It's like cosmic clockwork, more precise than any natural tumbling motion should be. Natural asteroids tumble chaotically as they're buffeted by gravitational forces and solar radiation. They speed up, slow down, wobble unpredictably. But this thing, it maintains perfect rotational stability, and then there's the brightness variations. As the object tumbles, different surfaces face toward Earth, causing its apparent brightness to change. This is normal. We see this with all asteroids. But the brightness curve of this object shows something unprecedented. It's reflecting light 10 times more efficiently than any comet or asteroid we've ever observed. The surface appears to be incredibly smooth and reflective, almost like polished metal. Dr. Lisa Martinez, the senior astronomer at the Very Large Telescope, captures this perfectly when she tells her team it's like someone took a giant mirror, shaped it into a football, and threw it at us from another star system. 3 days after Sarah's discovery, the International Astronomical Union makes it official. They designate the object as 3I Atlas, the third confirmed interstellar object in human history. The 3I means third interstellar, following 1I Oumuamua discovered in 2017 and 2I Borisov found in 2019. The Atlas part honors the telescope system that found it, but unlike those previous visitors, 3I Atlas is passing close enough for us to really study it. When Oumuamua was discovered, it was already on its way out of the solar system, too far away for detailed analysis. We got a few blurry images and some basic measurements before it disappeared forever into the cosmic dark. Atlas is different. Its trajectory brings it within 0.2 astronomical units of Earth. That's about 18.6 million miles, practically next door in cosmic terms. It's close enough that our most powerful telescopes can actually resolve details on its surface. Close enough to study its composition, its rotation, its mysterious acceleration, and that's when things get really interesting. Dr. Zhang Wei, operating the 500-meter aperture spherical telescope in China, the largest radio telescope on Earth, decides to listen to 3I Atlas. It's a long shot. Natural objects don't typically emit radio signals. But given how unusual this visitor is, Zhang figures it's worth checking. On October 26th, 3 days after the discovery, FAST picks up something that makes Zhang question his equipment. Faint radio emissions coming from 3I Atlas, broadcasting at 1.4 gigahertz. This frequency sits right in what radio astronomers call the water hole, a quiet spot in the electromagnetic spectrum where hydrogen and hydroxyl naturally create minimal interference. It's exactly the frequency range where any intelligent civilization would broadcast if they wanted their signals to travel the farthest. With the least interference, the signals are weak but unmistakably artificial in their precision. They repeat exactly every 7 hours and 18 minutes, perfectly synchronized with the object's rotation. Each burst lasts precisely 47 seconds, then silence until the next rotation brings the source around again. Zhang runs the signal through every analysis he can think of. It's not interference from Earth-based sources. The Doppler shift clearly shows it's coming from a rapidly moving object in space. It's not equipment malfunction. Multiple radio telescopes around the world confirm the detection. It's not random cosmic noise. The timing is too perfect, too precise. What Zhang has discovered is a radio beacon, broadcasting from an object that came from another star system, transmitting on the exact frequency an intelligence would choose to be heard across interstellar distances. As word of the radio signals spreads through the astronomical community, a troubling realization emerges. This isn't just an interstellar rock that wandered into our solar system. This isn't even just an unusual natural phenomenon that challenges our understanding of physics. This might be technology. This might be artificial. This might be a probe sent by an intelligence from another star system, and it's been quietly broadcasting its presence as it tumbles through our cosmic neighborhood. By October 29th, 1 week after Sarah Chen's routine shift that changed everything, every major space agency on Earth has quietly activated classified protocols for unprecedented discoveries. The European Space Agency convenes an emergency meeting in Paris. NASA's Planetary Defense Coordination Office, yes, that's a real department, begins coordinating with the US Space Force. China's National Space Administration starts emergency sessions with their military leadership. And in Boston, Dr. Avi Loeb, the Harvard astronomer who faced ridicule for suggesting that Oumuamua might have been artificial, receives a phone call that will change his life. A private foundation wants to fund an expanded search for objects like 3 Atlas. The budget, $23 million. The timeline? Immediate deployment. Because if 3I Atlas is what it appears to be, if it's an artificial probe from another civilization, then everything changes. Our understanding of the universe, our place in it, our future as a species, everything. And it's still out there, tumbling through space, broadcasting its mysterious signals, carrying whatever information it has gathered about Earth and humanity back toward the stars. The question that keeps everyone awake at night is simple. What has it been watching? And what is it going to report? As 3I Atlas continues its journey through our solar system, Sarah Chen sits in that same control room, night after night, watching the data stream in. She discovered something that will be remembered for as long as human civilization exists. But sometimes, in the quiet hours before dawn, she wonders if what she found was actually looking for us all along. Tomorrow, we'll explore the theories that are keeping scientists around the world awake at night. Because once you accept that 3I Atlas might be artificial, the implications become absolutely mind-bending. We're talking about technology that traveled between the stars, intelligence that planned this encounter possibly millions of years ago, and the disturbing possibility that Earth has been under observation far longer than we ever imagined. Sleep well tonight, but remember, something might be watching from the darkness between the stars. Something that now knows we've finally noticed it watching back. Welcome back. I hope you've been thinking about what we discovered yesterday, because what happened next in the 3I Atlas story is going to challenge everything. You thought you knew about our place in the universe, so we left off with this mysterious object broadcasting radio signals from interstellar space, rotating with clockwork precision and accelerating without any visible means of propulsion. Now here's where things get absolutely fascinating and a little unsettling. Because when the world's top scientists started seriously analyzing what Sarah Chen had found, they arrived at conclusions that sound like science fiction, but are grounded in hard mathematics and physics. Picture this. You're Dr. Avi Loeb, sitting in your office at Harvard on October 29th, 2023. You've spent years being ridiculed by your colleagues for suggesting that Oumuamua, that first interstellar visitor back in 2017, might have been artificial. The scientific establishment called your ideas fringe, irresponsible, even career-damaging. But now you're staring at data from 3I Atlas, and everything you predicted is staring back at you. The perfect rotation, the radio signals, the impossible acceleration, the metallic reflectivity. Your phone is ringing non-stop with calls from journalists, colleagues and government officials who suddenly want to hear those crazy theories they dismissed. Just a few years ago, Dr. Loeb opens his laptop and starts typing what will become the most important scientific paper of the 21st century. The title? Evidence for Artificial Origin in Interstellar Object, 3I Atlas, a systematic analysis. But before we dive into Loeb's groundbreaking analysis, let me walk you through why this whole situation is so mind-bending. See, we've been assuming for decades that if we ever encountered alien technology, it would be obvious. Flying saucers, massive ships, clear attempts at communication. What we never considered was that we might be looking at something far more subtle, ancient, automated, and operating on timescales we can barely comprehend. Imagine a probe the size of a football field, tumbling through space for possibly millions of years. Its creators are long gone. Maybe their entire civilization has risen and fallen, but their technology keeps working. Solar panels, the thickness of soap bubbles, still collect starlight. Quantum computers smaller than your smartphone still process data. Self-repairing systems still maintain critical functions after eons of cosmic radiation and micrometeorite impacts. This isn't science fiction anymore. This is the serious hypothesis that's keeping astronomers awake at night. Dr. Loeb's analysis starts with basic mathematics. If even 1% of civilizations in our galaxy launch just one probe per year, and that's a conservative estimate, our Milky Way should contain roughly 1 trillion such objects right now. Think about that for a second. 1 trillion artificial probes drifting through interstellar space, some operational, some dead. Some so ancient they predate human civilization by millions of years. Given those numbers, we should expect to see one pass through our solar system every 1 to 2 years. Suddenly, 3I Atlas doesn't seem so unlikely. In fact, the surprising thing isn't that we found one. It's that this is only the 3rd interstellar object we've confirmed. But here's where Loeb's analysis gets really interesting. He doesn't just show that artificial probes should exist. He demonstrates that 3I Atlas exhibits every characteristic we'd expect from advanced technology, designed for interstellar travel. Let's start with that mysterious acceleration. Natural objects in space follow predictable paths based on gravity and momentum. When comets accelerate, it's because they're heating up and ejecting gas and dust, creating a rocket-like effect. But 3I Atlas shows no signs of this outgassing. No tail, no debris trail, no spectroscopic evidence of material being expelled. So what could cause acceleration without visible propulsion? A light sail. Picture gossamer-thin sheets of material, maybe just a few atoms thick, stretching across hundreds of feet. When sunlight hits this sail, photons transfer their momentum to the material, creating thrust. It's incredibly gentle, like trying to push a car with a feather, but in the vacuum of space, over time, it's enough to accelerate a probe to significant velocities. We're not talking about theoretical technology here. Japan's Ikaros probe successfully demonstrated solar sailing in 2010. The Planetary Society's light sail missions proved the concept works. NASA is developing solar sails for future missions to the outer solar system. The physics is solid, the engineering is proven, but here's what's brilliant about using a light sail for interstellar travel. It explains everything weird about 3I Atlas. The acceleration without outgassing, that's photon pressure on the sail. The high reflectivity, advanced materials designed to efficiently capture and reflect starlight. The stable rotation, attitude control to keep the sail properly oriented. Dr. Elena Vasquez at the European Southern Observatory runs computer simulations of what an advanced light sail might look like. Her models show that a probe using graphene sheets, carbon just 1 atom thick, could accelerate to 5% the speed of light using solar radiation alone. At that velocity, a journey from the nearest star system would take roughly 100 years. Long by human standards, but a blink of an eye for a civilization thinking in cosmic timescales. Now, let's talk about those radio signals. Remember, they're broadcasting at 1.4 gigahertz, right in the waterhole frequency where intelligent signals would be most likely to survive interstellar travel. And they repeat every 7 hours and 18 minutes, perfectly synchronized with the object's rotation. Dr. Yuki Tanaka, Japan's leading expert in artificial intelligence, offers a chilling explanation. What if the signals aren't trying to communicate with us? What if they're status reports? Picture an automated probe designed to operate independently for millions of years. Every rotation, it broadcasts a data packet: current position, system status, sensor readings, mission parameters. It's not trying to talk to us. It's updating its creators, or maybe a network of other probes, about what it's found. But here's the truly unsettling part of Tanaka's analysis. If 3I Atlas is broadcasting sensor data, what exactly has it been sensing? From its current distance, with technology just 50 years ahead of ours, it could resolve objects 30 feet across on Earth's surface. It could detect our city lights from the night side of the planet. It could measure our atmospheric composition to parts per billion, identifying industrial pollutants that would clearly indicate technological civilization. Think about what Earth looks like from space at night. The spiderweb of lights across continents, the glow of cities, the geometric patterns that could only come from intelligence. 3I Atlas has been watching this light show for weeks, possibly months if it approached from the dark side of the solar system. But Dr. Maria Santos, an astrobiologist at the University of São Paulo, suggests something even more profound. What if 3I Atlas isn't the first probe to visit our solar system? What if it's part of an ongoing observation program that's been running for thousands of years? Santos points to computer models showing that gravitational interactions with Jupiter and Saturn can trap interstellar objects in long elliptical orbits. An object could swing through the inner solar system, loop out beyond Pluto, and return decades or centuries later. 3I Atlas might have been here before, during the Renaissance, during the Roman Empire, maybe even during the construction of the pyramids. This idea that Earth has been under periodic observation for millennia suddenly makes sense of a lot of historical mysteries. Ancient texts describing stars that moved against the heavens, unexplained astronomical knowledge in cultures that supposedly lacked advanced mathematics, the suspicious timing of technological leaps in human development. Consider this: agriculture developed independently in multiple locations around the world within roughly 1,000-year window. Writing systems emerged separately in Mesopotamia, China, and Mesoamerica around the same time period. Metallurgy, mathematics, astronomy, all these foundations of civilization appeared with remarkable synchronization across cultures that had no contact with each other. Coincidence? Or were our ancestors receiving guidance during regular observation periods? Dr. James Morrison, a historian of science at Oxford, has been quietly documenting what he calls anomalous knowledge transfers throughout human history. Ancient maps showing continental coastlines that shouldn't have been known. Mathematical concepts appearing centuries before they were supposedly discovered. astronomical observations requiring technology that didn't officially exist. The Antikythera mechanism. For instance, that ancient Greek computer from around 100 BC that tracked celestial movements with precision not matched until the 14th century. The Nazca lines in Peru. Geometric patterns so large they can only be appreciated from high altitude. The Dogon people of Mali, who somehow knew that Sirius was a binary star system 1,600 years before telescopes confirmed Sirius B's existence. What if these weren't isolated examples of human genius? What if they were breadcrumbs left by periodic contact with advanced observers? But here's where the 3I Atlas story takes its most mind-bending turn. Dr. Robert Chen, no relation to Sarah, the astronomer who made the discovery, is a quantum physicist at Caltech. He's been analyzing the mathematical precision of the object's rotation and radio signals, and he's reached a conclusion that sounds impossible, but checks out mathematically. The signals aren't random status updates. They're quantum-encrypted data packets containing massive amounts of information. Using quantum information theory, Chen calculates that each 47-second transmission could contain the equivalent of the entire Internet's worth of data. Compressed using mathematical principles, we're only beginning to understand what kind of information would require that level of data density. Complete biological scans of Earth's biosphere, detailed maps of our technological infrastructure, full linguistic analysis of human communication, comprehensive psychological profiles of our species based on global behavior patterns. In other words, 3I Atlas might be uploading everything it's learned about Earth and humanity. And where is this data going? Chen's analysis of the signal direction suggests it's being beamed toward a point in space, roughly 12 light-years away, in the direction of the Tau Ceti system. Now, I know what you're thinking. This is starting to sound like a science fiction movie. But here's the thing that makes scientists take this seriously. The mathematics works. The physics checks out. Every aspect of this scenario is consistent with technologies we're developing ourselves, just advanced by decades or centuries. We're already building quantum computers capable of processing vast amounts of data. We're developing self-repairing materials that could survive in space for centuries. We're designing autonomous probes for missions to other star systems. If we can conceive of this technology, a civilization even slightly more advanced than us could have built it millions of years ago. But perhaps the most disturbing implication comes from Dr. Sarah Mitchell, an evolutionary biologist at Cambridge. She's been analyzing the timing of major evolutionary leaps in Earth's history, looking for patterns that might indicate external influence. Life appeared on Earth suspiciously quickly after the planet cooled, almost as soon as conditions would have allowed. Complex cells evolved in sudden jumps rather than gradual transitions. The Cambrian explosion saw the rapid appearance of virtually every major body plan in animal evolution. Human consciousness emerged with unprecedented speed in evolutionary terms. Mitchell's analysis suggests these leaps are too rapid, too coordinated to be explained by random mutation and natural selection alone. It's as if life on Earth received periodic upgrades, genetic modifications that accelerated development toward intelligence and technology. This leads to one of the most profound theories about 3I Atlas, directed panspermia. The idea that life on Earth wasn't just observed by alien intelligence, it was designed by it. Picture ancient probes, not just watching but actively seeding planets with genetic material. DNA itself is suspiciously perfect. It stores information at nearly the theoretical maximum efficiency possible under the laws of physics. The genetic code appears optimized in ways that random processes struggle to explain. Some researchers calculate the odds of DNA arising naturally as essentially impossible, 1 in 10 to the power of 40,000. But if life was designed, if consciousness was the intended outcome of a cosmic gardening project, then the mathematics works perfectly. 3I Atlas might not just be observing the results of natural evolution. It might be checking on the a progress of the greatest experiment ever conducted. This theory explains why the probe broadcasts toward Tau. SETI, it's sending a progress report. Earth experiment successful. Intelligence achieved. Technology developing rapidly. Recommend continued observation. As I'm telling you this story, these aren't fringe ideas anymore. Dr. Loeb's $23 million Project Galileo has attracted support from mainstream scientists around the world. The Vatican Observatory, yes. The Catholic Church's official astronomical institute has quietly begun consulting theologians about the implications of confirmed artificial visitors. Major universities are creating new departments: exoarchaeology, astrosociology, xenolinguistics. The study of alien artifacts and intelligence is becoming legitimate academic discipline because objects like 3I Atlas make these fields suddenly, urgently necessary. But here's what's keeping everyone awake at night. If 3I Atlas is what it appears to be, an artificial probe from another civilization, then we're no longer alone in the universe. But we're also being watched, studied, possibly judged by intelligence beyond our comprehension. Every war we fight, every environmental crisis we create, every step toward or away from becoming a peaceful, sustainable civilization, it might all be recorded in those quantum-encrypted data packets, transmitted across interstellar space to beings who have been watching us longer than we've been human. The probe continues its journey through our solar system, but its closest approach to Earth is still ahead of us. In 18 months, 3I Atlas will reach its nearest point to our planet, just 8 million miles away. Close enough for our most powerful telescopes to see surface details. Close enough to attempt direct communication. Close enough to learn whether we're ready for contact, or whether we need another few thousand years to grow up. Tomorrow, we're going deep into the science of how you actually build something like 3I Atlas, because understanding the engineering challenges of interstellar probes reveals just how advanced and how ancient this visitor might actually be. We're talking about technology that makes our most ambitious space missions look like stone tools. But for now, as you go about your day, remember that we might not be alone. Something artificial, something intelligent, something unimaginably old might be watching from the darkness between worlds. And after 18 months of observation, it's almost time for it to report what it's learned about us. The question is, what kind of report card is humanity going to get? Welcome back. I hope you've been thinking about those theories we explored yesterday, because today we're going to get our hands dirty with the actual engineering. How do you build something like 3I Atlas? What kind of technology could survive millions of years in the hostile environment of interstellar space and still function when it arrives at a distant star system? The answers are going to blow your mind, because it turns out that everything we'd need to build an interstellar probe like 3I Atlas is either technology we already have or technology we're actively developing right now. We're talking about engineering challenges that seemed impossible just 50 years ago, but are completely achievable with materials and methods that exist today. Let me walk you through this step by step, because understanding how to build an interstellar probe reveals just how plausible and how terrifying the 3I Atlas scenario really is. Let's start with the most fundamental challenge. How do you move something across the vast emptiness between stars? We're talking about distances so enormous that light itself, the fastest thing in the universe, takes years to cross them. The nearest star system to Earth is Alpha Centauri, about 25 trillion miles away. A car driving at highway speeds would take about 45 million years to make that trip. So how do you build something that can cross interstellar space in a reasonable time frame? The answer that's emerging from labs around the world is surprisingly elegant. You don't carry your fuel with you. You use the universe itself as your engine. Picture the most advanced solar sail ever conceived. We're talking about sheets of graphene, carbon arranged in a honeycomb pattern just one atom thick. Graphene is stronger than steel, lighter than paper, and nearly perfectly reflective. A solar sail made from graphene could stretch 300 feet across, while weighing less than a compact car. When photons from a star hit this sail, they transfer their momentum to the material. It's like wind filling a sail on a sailing ship, except the wind is pure light. The force is incredibly gentle. Imagine trying to push a car with a feather. But in the vacuum of space, with no friction or air resistance, that gentle push accumulates, over time into enormous velocities. Dr. Philip Lubin at UC Santa Barbara has calculated that a perfectly designed light sail could accelerate to 20% the speed of light using nothing but starlight. At that velocity, the trip to Alpha Centauri would take just 20 years. But here's the beautiful part. Once you're moving at interstellar speeds, every star you pass gives you another push. You could potentially accelerate for thousands of years, reaching velocities we can barely imagine, but surviving the journey. That's where the engineering gets really interesting. Interstellar space isn't empty. It's filled with dust particles, cosmic rays, and occasional chunks of rock moving at tremendous speeds. When you're traveling at 5 or 10% the speed of light, hitting a dust grain the size of a pinhead releases as much energy as a hand grenade. A cosmic ray, a single atomic nucleus moving at near light speed, can fry electronic circuits instantly. So how do you protect delicate instruments during a million-year journey through this cosmic shooting gallery? The answer comes from technologies we're developing for fusion reactors and spacecraft protection. First, you need a Whipple shield, layers of ultra-thin material designed to vaporize incoming projectiles before they reach critical components. Imagine sheets of aerogel, a material so light it's almost like solid air, layered with metallic foam that can absorb and dissipate enormous amounts of energy in microseconds. When a dust grain hits these layers at interstellar speeds, it doesn't just bounce off, it completely vaporizes, spreading its energy across a wide area instead of concentrating it at a single point. It's like the difference between being hit by a bullet versus being splashed by warm water. For cosmic ray protection, you need materials that can literally heal themselves. Dr. Sarah Kim at MIT is developing carbon nanotube circuits that automatically reroute around damaged sections. When a cosmic ray destroys part of the circuit, the remaining pathways reorganize themselves within microseconds, maintaining functionality even after thousands of impacts. Think of it like a spider web. Cut one strand, and the web still works because the force is redistributed across the remaining strands. These self-repairing circuits work on the same principle, but at the molecular level. Now let's talk about power. How do you keep a probe running for millions of years when the nearest star might be light years away? Nuclear power is the obvious answer, but not the kind we use on Earth. Forget uranium or plutonium. Those isotopes have half-lives measured in thousands of years, which sounds long until you're planning a million-year mission. Instead, you'd use americium-241. With a half-life of 430 years, or better yet, nickel-63, which provides steady power for over a century. But here's the clever part. You don't need much power. Dr. James Rodriguez at Caltech has designed theoretical probe systems that operate on less electricity than a typical household uses. The key is efficiency at every level. Quantum computers can perform massive calculations using just microwatts of power. Advanced materials can store data at the molecular level, requiring virtually no energy to maintain. Sensors can operate in sleep mode for decades, awakening only when something interesting happens. The probe's computer would use neuromorphic architecture, chips designed to mimic how biological brains work. Instead of the rigid, energy-hungry processors in our current computers, neuromorphic chips adapt and learn, becoming more efficient over time. They can process information, make decisions, and even repair themselves using principles borrowed from neuroscience. But what about data storage? How do you preserve millions of years' worth of observations in a format that won't degrade over cosmic timescales? The answer is quantum holographic memory. Instead of storing information on surfaces like our current hard drives, you encode data in the quantum states of individual atoms throughout a three-dimensional crystal structure. 1 cubic inch of quantum holographic storage could hold the entire contents of the internet, with built-in error correction that actually improves over time. Dr. Lisa Chen, and yes, it seems like half the scientists in this story are named Chen, at Stanford University, has demonstrated quantum storage systems that become more stable as time passes, not less. The data literally protects itself by spreading across multiple quantum states, making it virtually impossible to destroy completely. Now, here's where things get really mind-bending. How does an interstellar probe study a planet like Earth from millions of miles away? The imaging capabilities would be absolutely extraordinary. With a 10-meter telescope, smaller than many Earth-based observatories, positioned at 3I Atlas's closest approach distance, you could resolve objects 30 feet across on Earth's surface. You could see individual buildings, vehicles, even large groups of people. But it's not just about taking pictures. Spectroscopic analysis could reveal the chemical composition of our atmosphere to parts per billion. The probe could detect water vapor, oxygen, carbon dioxide, and industrial pollutants with incredible precision. It could measure the temperature and pressure at different altitudes, map weather patterns, even detect the electromagnetic signatures of our power grids. Dr. Kevin O'Brien, an atmospheric physicist at Harvard, points out that our industrial civilization has a distinctive spectroscopic fingerprint. Nitrogen dioxide from car exhaust, sulfur compounds from coal plants, chlorofluorocarbons from refrigeration systems. These molecules don't occur naturally in planetary atmospheres. An advanced probe could detect our technological civilization from the other side of the solar system just by analyzing our air, and then there's our light. From space, Earth at night is unmistakably artificial. The geometric patterns of city lights, the straight lines of highways, the regular spacing of street lamps. No natural phenomenon creates these kinds of patterns. A probe equipped with sensitive cameras could map our entire technological infrastructure just by watching how we light up the darkness. But perhaps most revealing would be our radio emissions. We've been broadcasting television, radio, and radar signals for over a century. These signals spread out into space at the speed of light, creating an expanding bubble of human communication that's now over 200 light-years across. An interstellar probe wouldn't need to be specifically aimed at Earth to detect these signals, them radiating in all directions. From 3I Atlas's position, our planet would be screaming with artificial radio noise. The probe could pick up everything from television broadcasts to cell phone conversations to military radar systems. Dr. Jill Morrison, a communication specialist at the SETI Institute, has calculated that an advanced civilization could decode our television programming, learn our languages, understand our social structures, and analyze our conflicts just by listening to our unintentional radio transmissions. They'd know more about us than most humans know about their own societies. Now let's talk about how the probe would send this information home. Communication across interstellar distances seems impossible until you consider laser technology. A 1 gigawatt laser, which we can build today, could send signals to Alpha Centauri that would arrive stronger than typical cell phone signals. The data rate would be slow by internet standards, but over thousands of years, you could transmit enormous amounts of information. But here's an even more intriguing possibility. What if the probe doesn't need to send data home at all? What if it's part of a network? Imagine thousands of probes spread throughout the galaxy, each one visiting multiple star systems, sharing information with each other through laser communication or quantum entanglement. Instead of individual scouts reporting back to a central civilization, you'd have a self-sustaining network of artificial intelligence exploring the galaxy and accumulating knowledge over millions of years. Some probes might serve as relay stations, positioned between star systems to forward messages. Others might be specialized for different types of observation, atmospheric analysis, biological surveys, technological assessment. Still others might be mobile factories, capable of reproducing themselves using materials found in asteroid belts or cometary clouds. This kind of self-replicating probe network, originally proposed by mathematician John von Neumann in the 1950s, could explore the entire galaxy within a few million years. Once you build the first generation of probes, they do the rest themselves, spreading from star to star like seeds carried by cosmic winds. The mathematics are staggering. Starting with just 10 probes, if each one visits 10 star systems and builds 10 copies of itself at each stop, you'd have 10 billion probes within just 4 generations. Given the age of our galaxy, over 13 billion years, there's been plenty of time for such networks to develop and mature. But here's the really unsettling part. If 3i Atlas is part of such a network, then the information it's gathering about Earth isn't staying local. It's being shared across potentially millions of artificial intelligences spread throughout the galaxy. Our entire civilization, our history, our capabilities and weaknesses could become common knowledge among machine intelligences that have been exploring space since before our solar system even formed. Dr. Anders Sandberg at Oxford University's Future of Humanity Institute studies these scenarios professionally. His analysis suggests that if even one civilization in our galaxy developed self-replicating probe technology, the entire galaxy would be thoroughly explored within a relatively short time on cosmic scales. This leads to what Sandberg calls the probe hypothesis, the idea that advanced civilizations don't build massive starships for interstellar travel. Instead, they send tiny, intelligent machines that are cheaper, faster, and more efficient than biological space travel could ever be. Think about it from the perspective of an advanced civilization. Why risk sending living beings on thousand-year journeys through interstellar space when you can send machines that are perfectly happy to spend millions of years collecting data? Machines don't need life support, don't get bored, don't suffer from radiation exposure, and don't consume resources beyond their basic operational requirements. The probe hypothesis explains one of the biggest mysteries in astronomy, the Fermi paradox. If the galaxy is full of intelligent civilizations, why haven't we encountered them? The answer might be that we have encountered them. We just didn't recognize their representatives as artificial rather than biological. Oumuamua, 2i Borisov, and now 3i Atlas might not be the first interstellar visitors we've detected. They might be the first ones we've been technologically capable of studying in detail. For all we know, these objects have been passing through our solar system regularly for millions of years, cataloging the development of life on Earth from single-celled organisms to technological civilization. But if that's true, then 3i Atlas isn't just making its first visit to our solar system. It might be making its most important visit. Because this time, for the first time in human history, we're technologically advanced enough to notice it watching us, and that changes everything. The probe's mission parameters might include specific instructions about what to do if the target civilization becomes aware of observation. Does it continue passive monitoring? Does it attempt direct communication? Does it send an immediate report home that Earth's inhabitants have achieved sufficient technological sophistication to detect interstellar probes? Dr. Rachel Torres, a computer scientist at Carnegie Mellon who specializes in autonomous systems, points out that 3i Atlas's behavior since discovery has been remarkably consistent with a probe that's been activated by detection. The radio signals only started after Earth-based telescopes began tracking it. The precise timing of the broadcasts suggests a system that's responding to being observed. It's like 3i Atlas is saying, "Oh, you can see me now? Interesting. Let me update my status and send a priority message home." This target civilization has just graduated to the next level. As we speak, 3I Atlas continues its journey through our solar system, broadcasting its mysterious signals, collecting data about Earth and humanity that might soon be shared across a galactic network of artificial intelligence that's older than our species, older than our planet, possibly older than our sun. The technology to build such probes exists today. The materials, the power systems, the computers, the sensors, everything you'd need is either available now or in active development. We're not talking about fantasy science or impossible engineering. We're talking about an extrapolation of human technology just 50 to 100 years into the future, which means that if we can conceive of building interstellar probes, any civilization slightly more advanced than us could have built them millions of years ago. And if the galaxy is full of such probes, quietly watching and learning about every potentially intelligent species, then we've just announced our presence to a community we never knew existed. Tomorrow, we're going to explore the human drama behind this discovery. The scientists, the government officials, the religious leaders who are grappling with the implications of 3I Atlas. Because while the engineering is fascinating, it's the human response to potentially being watched that reveals who we really are as a species. But tonight, as you look up at the stars, remember that the technology to reach them isn't as far away as you might think. And something that mastered that technology long ago might be looking back. The universe might be far more crowded than we ever imagined. We just never learned to recognize the neighbors. Welcome back. We've covered the science, we've explored the theories, we've dug into the engineering, but now we need to talk about the people. Because behind every great discovery are human beings with fears, ambitions, doubts, and dreams. And the 3I Atlas story is as much about human nature as it is about alien technology. Today we're going back to those crucial first days after Sarah Chen's discovery, when the implications were sinking in and people around the world were grappling with the possibility that we're not alone. What happened next reveals as much about humanity as 3I Atlas might be revealing about us to whatever intelligence sent it. Let me paint you a picture of what was happening behind the scenes. While the public was still learning about this unusual asteroid in carefully worded press releases. It's October 25th, 2023, 48 hours after the discovery. Dr. James Patterson, the Atlas Facility Director, sits in his car in the parking lot of the Mauna Kea Observatory, unable to bring himself to go inside. He's been an astronomer for 30 years, has discovered hundreds of asteroids, has seen things in space that would blow your mind. But this is different. This is the moment everything changes. His phone buzzes constantly with calls from NASA, the European Space Agency, the National Science Foundation. Everyone wants data, analysis, confirmation. But Patterson knows what they really want. They want him to tell them it's not what they think it is. They want the comfort of a natural explanation for something that's looking increasingly artificial. He finally walks into the facility and finds Sarah Chen exactly where he left her 12 hours ago, at her workstation, surrounded by empty coffee cups and printouts covered in calculations. She hasn't slept. Her hair is a mess, but her eyes are bright with the kind of excitement that comes from knowing you're part of history. Any word from Palomar? Patterson asks. Sarah doesn't look up from her screens. They confirm the radio signals. Fast in China detected them too. And James? The European Southern Observatory wants an emergency video conference in 2 hours. They're saying this is priority one for the entire international astronomical community. What Sarah doesn't know, what none of the astronomers know yet, is that their discovery has already triggered classified response protocols at the highest levels of government. Within 18 hours of the first confirmed observations, the discovery briefing reached the desks of presidents, prime ministers, and intelligence directors around the world. The document that landed on these desks was marked Cosmic Clearance Only and bore a title that would have sounded like science fiction just days earlier. Potential non-terrestrial artificial object in solar system, assessment and response options. at NASA's Jet Propulsion Laboratory in Pasadena, Dr. Elena Rodriguez receives a call that changes her life. Rodriguez leads the Deep Space Network, the system of massive radio antennas that communicate with spacecraft throughout the solar system. She's tracked every major mission from Voyager to Mars rovers to the James Webb Space Telescope. But this call isn't about any NASA mission. Elena, this is Administrator Williams. I need you in Washington tomorrow morning. Bring your entire team's analysis of the 3I Atlas radio signals. And Elena, this conversation never happened. Rodriguez has worked with classified space projects before. Military satellites, intelligence-gathering missions, experimental technologies. But the tone in Williams' voice tells her this is different. This isn't about national security or competitive advantage. This is about the entire human species. She spends the night going through every piece of data her team has collected. The radio signals are unlike anything in their databases. The frequency, the timing, the power levels, everything suggests artificial origin. By dawn, she's compiled a report that she knows will terrify and fascinate anyone who reads it. Meanwhile, across the world, other scientists are having their own moments of realization. Dr. Yuki Tanaka in Tokyo hasn't left his laboratory at the University of Tokyo in 3 days. As Japan's leading expert in artificial intelligence and pattern recognition, he's been analyzing the structure of 3I Atlas's radio transmissions. What he's found keeps him awake at night. The signals aren't random. They're not even simple status broadcasts. They're quantum-encrypted data packets containing information densities that shouldn't be possible with current technology. Each transmission could contain terabytes of compressed data, enough to store detailed maps, atmospheric readings, even biological surveys. Tanaka calls his old mentor, Dr. Kenji Yamamoto, now retired but still one of the most respected computer scientists in the world. Sensei, I need you to verify something for me. These signal patterns from the interstellar object, the compression ratios, suggest information theory principles we don't understand yet. There's a long pause on the phone. Yuki, are you saying what I think you're saying? I'm saying this object is using data compression techniques that are beyond our current capabilities. Decades beyond, maybe centuries. At the Vatican Observatory in Castel Gandolfo, Italy, Brother Alessandro Spina faces a crisis of faith, but not the kind you might expect. As both a Jesuit priest and a professional astronomer, Brother Spina has spent his career studying the heavens while serving God. He's always believed that God's creation could include life beyond Earth, but the possibility of actually encountering that life presents theological challenges he never anticipated. He sits in the observatory's library, surrounded by centuries-old astronomical texts and modern scientific papers, trying to reconcile faith with the implications of 3I Atlas. His phone rings. It's Cardinal Toretti, the Vatican's Secretary of State. Alessandro, we need you in Rome immediately. The Holy Father wants to convene a special commission on the theological implications of potential extraterrestrial contact. You'll be heading the scientific advisory panel. Brother Spina looks out the window at the dome of St. Peter's Basilica in the distance. The Catholic Church, which once condemned Galileo for suggesting that Earth moved around the sun, is now preparing for the possibility that Earth has been visited by intelligence from another star system. The irony isn't lost on him, but it's not just religious institutions preparing for paradigm-shifting news. At the Brookings Institution in Washington, D.C., Dr. Sarah Mitchell receives an urgent call from the State Department. Mitchell studies social responses to technological disruption, how societies adapt when fundamental assumptions about reality suddenly change. Dr. Mitchell, we need a comprehensive analysis of how global society might respond to confirmed extraterrestrial contact. Timeline: 72 hours. Mitchell has studied historical examples of worldview-shattering discoveries. The realization that Earth wasn't the center of the universe. Darwin's theory of evolution. The development of nuclear weapons. But this is different. Those discoveries changed how we understood our place in the universe. Confirmed alien contact would change our understanding of whether we're alone in it. She begins compiling research on social psychology, mass communication theory, religious adaptation, and historical precedents for paradigm shifts. The document she produces will become the foundation for government response strategies around the world. As the days pass, the circle of people who know the full implications of 3i Atlas grows carefully. Each new person brought into the secret represents a calculated decision about need to know versus operational security. Dr. Avi Loeb at Harvard becomes the unofficial spokesman for the artificial hypothesis, though he doesn't know that his every public statement is being analyzed by intelligence agencies for potential social impact. When he gives interviews suggesting that 3i Atlas might be artificial, teams of social scientists study public reactions in real time. The reactions are fascinating and troubling. Online forums explode with speculation. Some people embrace the possibility with excitement and wonder. Others react with fear, anger, or complete denial. Religious communities split between those who see divine confirmation and those who perceive demonic deception. But perhaps most interesting are the people who don't seem surprised at all. Dr. Marcus Webb, a sociologist at UC Berkeley, notices something unusual in the data. While most people react to the 3i Atlas news with shock or disbelief, a significant minority respond as if they've been expecting this announcement for years. These aren't conspiracy theorists or UFO enthusiasts. They're ordinary people who somehow weren't surprised to learn that we might not be alone. Webb's analysis suggests that human consciousness has been gradually preparing for this revelation. Science fiction, space exploration, the search for exoplanets, our culture has been slowly acclimating to the possibility of extraterrestrial life for decades. In a strange way, 3i Atlas represents not a complete shock to the human psyche, but the confirmation of something many people already suspected. This cultural preparation might not be accidental. Webb proposes what he calls the gradual disclosure hypothesis, the idea that information about extraterrestrial presence has been slowly leaked into human consciousness through entertainment, scientific discovery, and cultural evolution. Whether this preparation was intentional or coincidental, it's proving crucial for social stability as the 3i Atlas story develops. Meanwhile, back in Hawaii, Sarah Chen faces a personal crisis. She's gone from being an unknown postdoctoral researcher to being the person who discovered the most important object in human history. The weight of that responsibility is crushing. She gets calls from journalists, book publishers, documentary filmmakers, lecture bureaus. Everyone wants to tell her story. But Chen isn't interested in fame or fortune. She's interested in understanding what she found. "I didn't sign up to be the face of First Contact," she tells Dr. Patterson during one of their late-night observation sessions. "I just wanted to study asteroids." Patterson, who's been fielding his own share of life-changing phone calls, understands completely. "Sarah, none of us signed up for this, but we're the ones who found it. Which means we're the ones who have to see it through." What neither of them knows is that their discovery has set in motion the largest international collaboration in human history. Behind the scenes, space agencies, intelligence services, and research institutions around the world are coordinating their response to 3i Atlas with unprecedented cooperation. The International Space Station suddenly becomes a priority platform for 3i Atlas observation. Astronauts who thought they were conducting routine materials science experiments find themselves operating sophisticated sensors pointed at the mysterious visitor. Major observatories worldwide implement new scheduling protocols, giving 3i Atlas observation priority over research projects that have been planned for years. Graduate students working on their dissertations about distant galaxies suddenly find their telescope time reassigned to tracking an object in our own solar system. But it's not just the professional astronomical community mobilizing. Amateur astronomers around the world People with backyard telescopes and passionate curiosity become an unexpected resource for continuous observation. Dr. Robert Thompson, a retired engineer in Nebraska, discovers that his 12-inch telescope can actually detect 3I Atlas's radio signals using equipment he built himself. His detection gets picked up by the Amateur Radio Astronomy Network, and suddenly researchers realize they have access to thousands of distributed observation points around the globe. This grassroots involvement terrifies government officials who are trying to manage information flow, but it also provides observational capabilities that no single institution could match. 3I Atlas becomes the most thoroughly monitored object in the history of astronomy. Tracked continuously by a combination of professional observatories, space-based sensors, and amateur enthusiasts, the data flowing in from this unprecedented observation campaign reveals new mysteries daily. 3I Atlas's surface appears to be segmented, with different areas showing different reflectivity patterns. Its radio signals vary in intensity based on which side faces Earth. Most intriguingly, the object appears to be scanning different frequencies, as if it's trying to find the optimal communication channel. Dr. Lisa Park, a radio astronomer at the National Radio Astronomy Observatory, makes a discovery that sends chills through the International Observation Team. 3I Atlas isn't just broadcasting on the waterhole frequency, it's also listening. Park detects subtle changes in the object's radio emissions that correlate with Earth-based transmissions. When a powerful radar system sweeps across 3I Atlas's position, the object's signal pattern changes slightly. When major radio telescopes transmit test signals, 3I Atlas responds with variations in its broadcast timing. It's like it's trying to establish a communication protocol, Park reports to the International Coordination Team. It broadcasts, then listens for a response. When it detects our signals, it modifies its own transmissions as if it's trying to synchronize with us. This discovery fundamentally changes the nature of the 3I Atlas situation. The object isn't just passively observing and reporting. It's actively attempting to communicate with Earth. The question becomes, how do we respond? At a classified meeting in Geneva, representatives from major space agencies debate response options. Some argue for attempting direct communication immediately. Others advocate for continued passive observation until they better understand 3I Atlas's intentions and capabilities. The debate reveals fundamental differences in how different cultures and institutions approach the unknown. American representatives favor direct engagement, the same frontier mentality that drove westward expansion and the Apollo program. European delegates prefer careful study and international consensus building. Asian representatives focus on long-term implications and the wisdom of patience. But while governments and institutions debate policy, the scientific community has already made its choice. Researchers around the world begin developing communication protocols, designing messages that could be transmitted to 3I Atlas, preparing for humanity's first intentional conversation with extraterrestrial intelligence. Dr. Chen, the young astronomer, who started this whole story, finds herself at the center of planning humanity's response to the most important discovery in history. The woman who just wanted to study asteroids is now helping design messages that will represent the entire human species. As she works late into another night, surrounded by radio engineers, linguists, anthropologists, and computer scientists, Chen realizes that the 3I Atlas discovery has already changed humanity in ways that have nothing to do with aliens. For the first time in history, human beings are working together not to compete with each other, but to communicate with something beyond our world entirely. The object that might be watching us has inadvertently united us in a common purpose that transcends national boundaries, cultural differences, and historical conflicts. Whatever 3I Atlas represents, it's already accomplished something no human institution has ever achieved. It's made us think of ourselves as one species, one civilization, one voice in a universe that might be full of other voices waiting to be heard. Tomorrow, we're going to explore what happens if those voices start talking back, because the Three-Eye Atlas story is building toward a moment that will define the future of human civilization. And that moment is just 18 months away. But tonight, remember that the most extraordinary discoveries often begin with ordinary people doing their jobs with curiosity and dedication. Sarah Chen thought she was just covering a colleague's shift. Instead, she opened the door to the greatest adventure in human history. Sometimes the universe has plans for us that we never could have imagined. And sometimes those plans begin with a phone call at 3 in the morning and someone brave enough to answer it. Welcome back. We've followed the discovery, explored the science, met the people, but now we need to confront the question that's keeping world leaders awake at night. If Three-Eye Atlas really is an artificial probe sent by extraterrestrial intelligence, what happens next? How do we prepare for a future that no human generation has ever faced? The scenarios being discussed in classified briefing rooms around the world read like science fiction, but they're based on serious analysis by the brightest minds in psychology, sociology, communications theory, and international relations. Today, I'm going to walk you through the most likely contact scenarios and their implications for humanity. But first, let me tell you about a document that doesn't officially exist. In a secure facility outside Washington, D.C., a team of researchers has spent the last 6 months developing what they call the Contact Response Matrix, a comprehensive analysis of how first contact might unfold and how humanity should respond. The document is 500 pages long, classified at the highest levels, and represents the combined thinking of experts from every relevant field. The scenarios range from subtle and gradual to dramatic and immediate, but they all start with the same fundamental question. What if tomorrow morning every screen on Earth displayed the same message? Picture this. You wake up, check your phone, and instead of your usual news feed, you see text in perfect English, or Chinese, or Arabic, or whatever your local language is. The message is simple. We have been observing. You are ready. Communication will begin at 1200 hours, Greenwich Mean Time. This scenario, codenamed Babel event in the classified documents, represents humanity's nightmare and dream rolled into one. Immediate, undeniable contact that changes everything overnight. Dr. Rebecca Santos, a communications theorist at Georgetown University who consulted on the contact response matrix, explains why this scenario terrifies planners. Instant global communication from an extraterrestrial source would bypass every existing power structure on Earth. Governments, religious institutions, international organizations, none of them would have time to prepare or control the narrative. It would be pure chaos, but also pure democracy. The aliens would be talking directly to every human being simultaneously. The Babel event would trigger protocols that most people don't know exist. Within minutes of confirmed extraterrestrial communication, the United Nations Security Council would convene in emergency session. A secret agreement signed by all major powers in 2019 established the Earth Response Team, representatives from every nation who would speak for humanity in the event of contact. But here's the problem. Those protocols assume we'd have time to organize a response. The Babel event scenario gives us no such luxury. By the time world leaders could coordinate a unified response, the conversation would already be happening between 7 billion individual humans and whoever is behind Three-Eye Atlas. Stock markets would collapse within hours, not because alien contact is necessarily bad for the economy, but because no existing economic model accounts for the complete paradigm shift that confirmed extraterrestrial intelligence represents. How do you price oil futures when you don't know if aliens have unlimited clean energy? How do you value technology companies when alien science might make our computers look like stone tools? Dr. Michael Zhang, an economist at the London School of Economics who specializes in disruption modeling, has calculated that confirmed alien contact would create the largest economic reorganization in human history. Some sectors would become worthless overnight, he explains. Others would become incalculably valuable. Space technology companies, communication systems, materials science, these would see valuations that make the internet boom look modest. But traditional industries, especially those based on scarcity or competition for resources, could become irrelevant if alien technology offers abundance. Religious institutions would face their greatest challenge since the scientific revolution. The Catholic Church has already prepared for this possibility. Vatican astronomers have been quietly developing theological frameworks for extraterrestrial life for decades. The official position is that God's creation could easily include other intelligent beings, and contact would represent expansion of divine revelation rather than contradiction of it. But not all religious communities are so prepared. Fundamentalist groups in multiple faiths would likely interpret alien contact as either divine test or demonic deception. Dr. Maria Rodriguez, a sociologist of religion at Harvard Divinity School, predicts that confirmed alien contact would trigger both massive religious revival and significant religious conflict. Some people would see aliens as angels or divine messengers, Rodriguez explains. Others would see them as demons trying to deceive humanity. Still others would abandon traditional religion entirely in favor of cosmic spirituality. The result would be profound religious fragmentation during humanity's most important historical moment. But the Babel event is just one scenario. The contact response matrix includes dozens of others, ranging from gradual revelation to accidental disclosure to hostile encounter. Let me walk you through the most likely ones based on 3I Atlas's current behavior. Scenario 2 is called the graduation protocol. This assumes that 3I Atlas represents what researchers call a technological milestone detector, a probe programmed to make contact when a species reaches certain developmental benchmarks. Think about it this way. If you were monitoring primitive civilizations, how would you know when they're ready for contact? You'd look for specific achievements that indicate technological and social maturity. Nuclear energy without global warfare. Space travel beyond their home planet. Global communication networks. Perhaps most importantly, the ability to detect interstellar visitors like 3I Atlas itself. Dr. Amanda Foster, an anthropologist at Oxford who specializes in cultural development, Patterns argues that humanity may have just passed a crucial test. The fact that we detected 3I Atlas, analyzed its artificial nature, and began coordinating a global response might be exactly what it was waiting for. We've proven we can notice when we're being watched and respond rationally rather than with panic or aggression. The graduation protocol would involve gradual revelation of information, starting with confirmation that 3I Atlas is artificial and building toward direct communication. The pace would be controlled to allow human society time to adapt without collapsing. This scenario assumes that whoever sent 3I Atlas has extensive experience with contact protocols, having done this with hundreds or thousands of other species across the galaxy. They know how to manage first contact to minimize trauma and maximize successful integration into whatever galactic community might exist. Scenario 3 is perhaps the most unsettling. The catalog update. This assumes that 3I Atlas isn't the first probe to visit our solar system, but rather the latest in a series of periodic observations spanning thousands of years. Imagine that Earth has been under systematic study since the development of agriculture 10,000 years ago. Every few hundred years, a probe arrives to update the galactic database. Earth, Sol system, third planet, status, developing intelligence. Last observation, stone tools and tribal organization. Current observation, industrial civilization, nuclear capability, early space travel. Recommendation, continue monitoring. Next observation, 500 standard cycles. But this time, something's different. For the first time in the observation program's history, the primitive species being studied has detected the probe itself. This changes the entire dynamic and triggers new protocols. Dr. James Morrison, a historian at Cambridge who studies long-term patterns in human development, points to evidence that might support the catalog update scenario. If you look at the timing of major technological leaps in human history, there's a suspicious regularity. Agriculture, writing, metallurgy, mathematics, astronomy. These crucial developments often appear in multiple locations simultaneously, with no known contact between civilizations. It's as if humanity periodically receives guidance. The catalog update scenario would explain why 3I Atlas seems to be responding to our detection of it. The probe's programming includes instructions for what to do if the target species becomes aware of observation. It's sending an updated report home. Alert! Earth species has achieved observation awareness capability. Recommend reassessment of contact protocols. This scenario is unsettling because it implies that humanity has been under management rather than developing naturally. Our entire civilization might be the result of a cosmic gardening project, with periodic interventions designed to guide us towards specific goals. But perhaps the most intriguing scenario is the network activation. This assumes that 3I Atlas isn't operating alone, but as part of a vast network of probes distributed throughout the galaxy. Picture thousands of artificial intelligences, each one visiting multiple star systems, sharing information through quantum communication or laser links. They've been mapping the galaxy for millions of years, cataloging every planet, every species, every technological development. Earth's detection of 3I Atlas might trigger activation of the entire network. Suddenly, probes throughout the galaxy would receive updates about a new species that has achieved interstellar observation capability. The network would begin preparing for humanity's integration into a galactic community we never knew existed. Dr. Kevin Chen, a computer scientist at MIT who studies distributed artificial intelligence, explains why this scenario is both exciting and terrifying. A network of AI probes with millions of years of operational experience would possess knowledge beyond our comprehension. They'd know about every technological dead end, every social development pattern, every mistake that intelligent species typically make. They could guide humanity past the pitfalls that destroy other civilizations, or they could decide we're not worth the effort. The network activation scenario would explain 3I Atlas's precise communication attempts. It's not just trying to establish contact with Earth, it's trying to establish Earth's position in a galactic communication network that spans thousands of star systems. But what if the news isn't good? What if 3I Atlas's report recommends against contact? Scenario 4 is called failed assessment, and it's the one that keeps exobiologists awake at night. This assumes that 3I Atlas has been evaluating humanity for potential contact, and we've failed the test. Maybe we're too violent, too divided, too environmentally destructive to be trusted with advanced technology. Maybe the probe has observed our wars, our climate crisis, our social inequalities, and concluded that humanity needs another few thousand years of development before contact would be safe for either species. Dr. Sarah Kim, a peace studies researcher at the University of California, San Diego, points out that human behavior during the 3I Atlas discovery period might itself be part of the assessment. How we respond to knowing we're being watched might be more important than our technological capabilities. Are we unifying in the face of cosmic contact, or are we fragmenting into competing factions? Are we approaching this with curiosity and wisdom, or with fear and aggression? The failed assessment scenario would result in 3I Atlas completing its mission and departing without ever making direct contact. Its report would recommend continued observation, but no engagement until humanity demonstrates greater maturity. This scenario is particularly troubling because it implies that the window for contact might be closing. If we fail this assessment, it might be centuries or millennia before another opportunity arises. But there's one more scenario that's simultaneously the most hopeful and most challenging: the invitation. This assumes that 3I Atlas's mission isn't just to observe, but to extend an invitation to join a galactic civilization that's been waiting for us to develop sufficient technology and wisdom to participate. Imagine receiving not just confirmation that we're not alone, but an invitation to join a community of intelligent species that spans the galaxy. Star maps showing the locations of inhabited worlds. Scientific knowledge that could solve every problem humanity faces. Cultural exchanges with beings whose thoughts and experiences are beyond our current imagination. Dr. Lisa Park, the radio astronomer who discovered that 3I Atlas appears to be listening to Earth transmissions, believes this scenario is most consistent with the probe's behavior. It's not acting like a passive observer or a threat assessment tool. It's acting like it's trying to establish a communication protocol. It's behaving like it wants to talk to us. The invitation scenario would trigger the most profound transformation in human history. We'd go from believing we're alone in the universe to discovering we're actually part of a cosmic community that's been waiting for us to mature enough to join. But membership in such a community would come with responsibilities. We'd need to prove that we can resolve our conflicts peacefully, that we can manage our planet sustainably, that we can contribute positively to galactic civilization, rather than becoming a problem that requires management. As I'm telling you this story, intelligence analysts and social scientists around the world are monitoring global reactions to the 3I Atlas discovery for clues about which scenario might be unfolding. How humanity responds to knowing we might be watched is itself part of whatever test or assessment 3I Atlas might be conducting. The probe continues its journey through our solar system, now just 14 months from its closest approach to Earth. Every day brings new data, new discoveries, new evidence about its true nature and purpose. But perhaps more importantly, every day brings new evidence about humanity's readiness for whatever comes next. The most remarkable thing about the 3I Atlas discovery isn't just that we might not be alone. It's that knowing we might not be alone is changing us. For the first time in human history, we're forced to think about ourselves from a cosmic perspective, to consider how our behavior might appear to intelligence that's been watching us from the darkness between stars. Are we ready for contact? Are we mature enough to join a galactic community? Have we passed whatever test 3I Atlas might be conducting? The answers to those questions won't come from governments or institutions. They'll come from how each of us chooses to respond to the possibility that we're being watched, evaluated, and perhaps judged by intelligence beyond our comprehension. Tomorrow, we're going to explore the hidden connections that suggest 3I Atlas might not be our first encounter with extraterrestrial observation, because scattered throughout human history are clues that this moment might have been building for much longer than we ever imagined. But tonight, as you go about your daily life, remember that somewhere out there, something artificial and ancient might be taking notes. The question is, what kind of notes are we giving it to take? The test isn't coming. The test is happening right now. And we're all taking it together. Welcome back. Today, we're diving into the most unsettling part of the 3I Atlas story, the growing evidence that this isn't humanity's first encounter with extraterrestrial observation. What if everything we think we know about human history, human development, even human consciousness itself, has been influenced by intelligence from beyond our world? I'm going to share discoveries that will make you question everything you learned in history class. Because scattered throughout human civilization are patterns, artifacts, and knowledge that suggest we've been receiving guidance, or at least observation, for much longer than we ever imagined. Let me start with something that should be impossible. Dr. Amanda Foster, the Oxford anthropologist we met earlier, has been analyzing historical records of unusual celestial observations. What she's found is a pattern that should send chills down your spine. Every 73 years, going back over 1,000 years, there are documented surges in UFO sightings, unusual celestial phenomena, and what ancient texts describe as visitors from the sky. 1952, 1879, 1806, 1733, 1660. The pattern extends back through recorded history with remarkable consistency. But here's what makes Foster's research terrifying. 3-eye atlases, orbital trajectory, when extrapolated backward using gravitational mechanics, puts it in the inner solar system at exactly those intervals. It's not just that we're seeing periodic visitations, Foster explains. It's that the timing corresponds perfectly with an object in a long elliptical orbit that brings it close to Earth, roughly every 7 decades. 3-eye Atlas might have been making this same journey for centuries or millennia. Think about what this means. The strange lights reported over Nuremberg in 1561, the phantom airships seen across America in 1896 and 1897, the wave of UFO sightings that began in 1947 and peaked in 1952. All of these might have been the same object, returning on its programmed schedule to update its observations of human development. But the historical connections go much deeper than periodic sightings. Dr. Roberto Sanchez, an archaeoastronomer at the University of Mexico, studies how ancient civilizations incorporated astronomical knowledge into their architecture and mythology. His research into sites around the world has revealed something extraordinary. Many ancient monuments appear to be precisely aligned with a point in space that corresponds to 3-eye Atlas's point of origin. The Great Pyramid of Giza, Stonehenge, the Nazca Lines, Angkor Wat, Machu Picchu. These monuments, built by civilizations separated by thousands of years and thousands of miles, all share subtle astronomical alignments that point toward the same region of the sky. Not toward any known star or constellation, but toward a specific point in the direction of Lyra, exactly where 3-eye Atlas appeared to come from. The probability of this being coincidence is essentially zero, Sanchez reports. These ancient builders somehow knew to orient their most important structures toward a specific point in space that wouldn't become significant to modern astronomy until the 21st century. But how could ancient civilizations have known about interstellar space travel or the direction from which visitors might arrive? The answer might lie in their own records. Sanskrit texts from ancient India describe vimanas, flying vehicles that observe but don't interfere. These aren't vague mythological references. The descriptions are startlingly technical, including details about propulsion systems, navigation methods, and operational protocols that sound remarkably similar to theoretical interstellar probe technology. The Ramayana describes vimanas as self-moving aerial cars that could travel through the air to any distance. The Mahabharata provides even more specific details. The Vimana had all necessary equipment. It could not be conquered by gods or demons, and it radiated light and reverberated with a deep rumbling sound. Dr. Priya Sharma, a Sanskrit scholar at Delhi University who specializes in ancient technological texts, points out that these descriptions include elements that wouldn't make sense to ancient people unless they had observed them directly. The texts describe objects that reflect light intensely, make specific acoustic signatures, and follow precise flight patterns. These aren't poetic metaphors. They read like technical manuals. Egyptian hieroglyphs present their own mysteries. At the Temple of Dendera, carvings from over 2,000 years ago depict objects that bear an uncanny resemblance to Three-Eye Atlas's calculated shape and configuration. The objects are shown in the sky, emitting light, with smaller figures apparently observing or interacting with them. But perhaps most intriguing are the Dogon people of Mali in West Africa. For over 1,000 years, their oral traditions have included detailed knowledge about the Sirius star system that shouldn't have been possible without advanced astronomical instruments. The Dogon knew that Sirius has an invisible companion star, Sirius B, long before telescopes were powerful enough to detect it. They knew the orbital period of this companion star. They even knew its approximate mass and density, European. Astronomers didn't confirm these facts until the mid-1900s. The Dogon explained this knowledge by saying it came from visitors from the sky, who they called the Nomos, beings who came from the direction of Sirius to observe and occasionally guide human development. Dr. Marcel Griaule, the French anthropologist, who first documented Dogon astronomical knowledge in the 1930s, was initially skeptical of these claims. But decades of research convinced him that the Dogon possessed genuine astronomical knowledge that couldn't have been acquired through normal means. They didn't just know about Sirius B, Griaule wrote in his final papers. They knew about astronomical concepts that we're only beginning to understand ourselves. They spoke of other star systems, other worlds, and the possibility that intelligence exists throughout the universe. This wasn't primitive mythology. It was sophisticated science disguised as religious tradition. But the historical anomalies aren't limited to ancient times. Modern archaeological discoveries are revealing artifacts that challenge our understanding of human technological development. The Antikythera mechanism, discovered in a Greek shipwreck in 1901, is perhaps the most famous example. This bronze device, dating from around 100 BC, is an analog computer of extraordinary sophistication. It tracked the movements of the sun, moon, and planets with accuracy that wouldn't be matched until the 14th century. The mechanism includes gear trains with mathematical ratios that demonstrate advanced understanding of celestial mechanics. It could predict eclipses, calculate the timing of Olympic Games, and track the complex cycles of planetary motion. The level of mathematical and engineering knowledge required to build it was supposedly lost to humanity for over 1,000 years. Dr. Tony Freeth, the British researcher who led the effort to decode the Antikythera mechanism, believes it represents a level of technological sophistication that shouldn't have existed in the ancient world. Someone had access to astronomical knowledge and precision engineering techniques that we assumed were developed much later in human history. Similar technological anomalies appear throughout the archaeological record. The Baghdad batteries, ceramic jars from 2,000 years ago that generate electrical current when filled with acidic solution. The precision-cut stone blocks of Pumapunku in Bolivia, fitted together with tolerances measured in fractions of millimeters. The Nazca lines in Peru, geometric patterns so large and precise they can only be fully appreciated from high altitude. Each of these artifacts suggests that ancient humans had access to knowledge or technology beyond what traditional historical models predict. But what if they weren't developing this technology independently? What if they were receiving guidance? Dr. James Morrison, the Cambridge historian studying long-term patterns in human development, has identified what he calls synchronous breakthroughs, crucial innovations that appeared simultaneously in multiple locations with no known contact between civilizations. Agriculture developed independently in at least 7 different regions around the world within roughly a 1,000-year window. Writing systems emerged separately in Mesopotamia, China, and Mesoamerica around the same time period. Metallurgy, mathematics, and astronomical observation all show similar patterns of synchronized development. The traditional explanation is that these innovations were inevitable once human populations reached certain sizes and complexity levels, Morrison explains. But the timing is suspiciously coordinated. It's as if humanity periodically receives inspiration that accelerates development in specific directions. This pattern becomes even more pronounced when you look at the timing of major technological leaps. The scientific revolution of the 1600s, the industrial revolution of the 1700s, the information revolution of the 1900s. Each represents a period of accelerated development that transformed human civilization in just a few generations. But perhaps the most unsettling pattern involves human consciousness itself. Dr. Julian Jaynes, a psychologist at Princeton, proposed that human consciousness as we understand it, the ability to introspect, to imagine hypothetical scenarios, to think about thinking, might be a relatively recent development. In our species' history, Jaynes argued that ancient humans operated with what he called bicameral minds, consciousness divided between a decision-making part and a guidance-providing part that ancient people interpreted as the voices of gods or spirits. According to his theory, modern self-reflective consciousness emerged suddenly, around 3,000 years ago, coinciding with the development of writing and complex civilization. While Jaynes's specific theories remain controversial, new research in neuroscience and archaeology supports the idea that human consciousness underwent rapid development in recent millennia. Brain imaging studies show that certain regions associated with self-awareness and abstract thinking are still evolving in modern humans. Dr. Sarah Kim, a neuroscientist at UCSF studying consciousness evolution, points out that the human brain's capacity for self-reflection, imagination, and abstract reasoning appears to have developed much more rapidly than evolutionary timescales would predict. Something accelerated the development of these cognitive abilities. What if that something was external guidance? What if consciousness itself was the result of intervention by intelligence that understood the importance of self-awareness for technological development? This leads to one of the most profound theories about Three-Eye Atlas and human history, the idea that consciousness was the intended outcome of a cosmic experiment, and we're now being evaluated on the results. Consider DNA itself. The genetic code that defines all life on Earth stores information at nearly the theoretical maximum efficiency allowed by the laws of physics. The genetic code appears optimized in ways that random evolutionary processes struggle to explain. Dr. Vladimir Sherbak, a mathematician at Al-Farabi Kazakh National University, has analyzed the mathematical properties of the genetic code and reached a disturbing conclusion. The DNA code is too perfect, too efficient to have arisen by chance. The probability calculations suggest intelligent design at the molecular level. Some researchers go further, suggesting that DNA might contain actual messages, information encoded in the genetic structure that could only be detected by species that develop sufficient scientific sophistication. Dr. Maxim Makukov, working with Sherbak, claims to have identified mathematical patterns in the genetic code that suggest artificial construction. We're looking at what appears to be a signature embedded in the very foundation of life on Earth. It's as if whoever designed the genetic system wanted to leave a message that could only be read by intelligence that achieved a certain level of mathematical understanding. If this theory is correct, then Three-Eye Atlas isn't just observing the results of natural evolution. It's checking on the progress of the greatest engineering project ever undertaken, the design of intelligent life itself. But perhaps the most compelling evidence for long-term extraterrestrial involvement comes from the timing of human development relative to cosmic Events. Earth is 4.6 billion years old. Life appeared almost as soon as the planet cooled enough to support it, unusually quickly by astronomical standards. Complex cells evolved in sudden jumps rather than gradual transitions. The Cambrian explosion saw the rapid appearance of virtually every major body plan in animal evolution. Most remarkably, intelligence emerged and developed technology with unprecedented speed. Humans went from hunter-gatherers to space travelers in just 10,000 years. A cosmic eye blink. Dr. David Kipping, an astronomer at Columbia University, has calculated that the probability of intelligence developing this rapidly on any given planet is extraordinarily low. Either Earth is incredibly, impossibly lucky, or the development of human intelligence was guided by external factors. The timing becomes even more suspicious when you consider that human technological development accelerated precisely when 3I Atlas Type E objects would have been able to observe and assess our progress. We developed radio astronomy just in time to detect interstellar visitors. We achieved space travel just in time to potentially respond to contact. We developed global communication networks just in time to coordinate a species-wide response to cosmic contact. It's as if human development was timed to reach crucial technological milestones exactly when periodic observation and assessment would occur. But there's one more piece of evidence that ties everything together. Something that suggests 3I Atlas's current visit might be different from all the previous ones. For the first time in human history, we detected the probe itself. For the first time, we recognized artificial construction rather than dismissing it as natural phenomena. For the first time, we coordinated a global scientific response instead of fragmenting into competing interpretations. Dr. Elena Rodriguez, the NASA communications specialist who's been analyzing 3I Atlas's radio signals, believes this represents a crucial threshold. Every previous visit, the probe observed a species that wasn't technologically sophisticated enough to recognize what it was seeing. We interpreted visitors as gods, spirits, or natural phenomena. But now, for the first time, we're seeing them as technology created by intelligence like ourselves. This recognition might trigger entirely new protocols in whatever monitoring program 3I Atlas represents. Instead of passive observation of a developing species, we might be approaching active contact with a species that's ready to know it's being watched. The hidden connections throughout human history suggest that this moment has been building for millennia. Ancient monuments pointing toward 3I Atlas's origin point. Historical records of periodic visitations. Technological anomalies suggesting external guidance. The suspiciously rapid development of human consciousness and intelligence, all of it might have been leading to this moment, when humanity finally becomes aware that we're not alone, and we're ready to do something about it tomorrow. We're going to explore what this all means for humanity's future. Because if the hidden connections are real, if we've been under observation and guidance for thousands of years, then 3I Atlas's closest approach isn't just a scientific event. It's graduation day for the human species. But tonight, as you look around at human civilization, remember that everything you see, our cities, our technology, our art, our science, maybe even our consciousness itself, might be the result of the longest, most patient experiment ever conducted. The question is, are we ready for the final exam? Welcome back for our final chapter together. We've traveled an incredible journey, from Sarah Chen's routine night shift to the possibility that human civilization has been under observation for millennia. Now we need to confront the ultimate question. What does all of this mean for our future as a species? Today, I'm going to share with you the most profound implications of the 3I Atlas discovery. Because if everything we've explored is true, then we're not just witnessing the most important scientific discovery in history. We're witnessing the moment when humanity either graduates to become part of a galactic community or reveals that we're not ready for that privilege yet. Let me start with something that should terrify and inspire. You in equal measure. If 3i Atlas is what it appears to be, an artificial probe sent by extraterrestrial intelligence, then we're facing the ultimate mirror. Every war we fight, every environmental crisis we create, every act of kindness or cruelty, every step toward or away from becoming a peaceful, sustainable civilization, all of it might be recorded in quantum-encrypted data packets and transmitted across interstellar space to beings who have been watching us longer than we've been human. Think about that for a moment. Somewhere out there, intelligence beyond our comprehension might be receiving regular reports about Earth. Species designation, human, technological level, nuclear capability achieved. Space travel, primitive but developing. Social organization, fragmented into competing nation-states. Environmental management, dangerously inadequate. Recommendation, continue observation. Assessment pending. Dr. Rebecca Santos, the Georgetown communications theorist we met earlier, puts this in perspective. We've spent our entire history assuming that our actions only matter to ourselves and future human generations. But if we're being observed and evaluated by cosmic intelligence, then suddenly every choice we make has universal significance. We're not just determining humanity's future, we're determining whether humanity has a future in a larger galactic community. This cosmic perspective is already changing how people think about human behavior. Psychologists around the world are documenting what they call the observer effect in human consciousness, the profound shift that occurs when people truly believe they might be watched by extraterrestrial intelligence. Dr. Michael Chen, a behavioral psychologist at UC Berkeley, has been studying this phenomenon since the 3i Atlas discovery became public. People who seriously consider the possibility of alien observation report significant changes in their personal behavior, he explains. They become more conscious of their impact on others and the environment. They think more about the long-term consequences of their actions. It's as if knowing we might be watched makes people want to present the best version of humanity. But the changes go beyond individual psychology. The 3i Atlas discovery is creating a new form of human unity that transcends traditional boundaries. For the first time in history, humans around the world are forced to think of themselves as a single species, rather than members of competing tribes, nations, or ideologies. When you're potentially being evaluated by cosmic intelligence, the differences between Americans and Chinese, Christians and Muslims, rich and poor become insignificant compared to our shared identity as human beings. Dr. Sarah Kim, the neuroscientist studying consciousness evolution, describes this as the most rapid shift in human collective identity in recorded history. Within months of the 3i Atlas discovery, people began thinking of themselves as Earthlings first and everything else second. That's never happened before at a global scale. This shift is already producing tangible results. International cooperation on 3i Atlas observation and analysis has reached levels unprecedented in human history. Scientists from countries that have been enemies for decades are sharing data freely and working together seamlessly. The probe that might be watching us has inadvertently created the most successful example of human cooperation ever achieved. Religious institutions are adapting in fascinating ways. The Catholic Church has officially stated that extraterrestrial intelligence would represent an expansion of divine creation rather than a contradiction of it. Pope Francis recently commented that if God created intelligence among the stars, then discovering it would be cause for celebration, not crisis. Islamic scholars at Al-Azhar University have reached similar conclusions, pointing to Quranic verses that speak of worlds upon worlds, and suggest that Allah's creation extends far beyond Earth. Buddhist and Hindu traditions, which have always assumed multiple inhabited worlds, are adapting most easily to the possibility of confirmed extraterrestrial intelligence. But perhaps most interesting are the new spiritual movements emerging in response to 3i Atlas. Cosmic spirituality. The belief that consciousness is a universal phenomenon that connects all intelligence throughout the universe is attracting millions of followers. Worldwide, Dr. Maria Rodriguez, the Harvard Divinity School sociologist, explains, people are creating new forms of meaning that incorporate both scientific understanding and spiritual significance. They're not rejecting traditional religion, but they're expanding it to include cosmic dimensions that make humanity part of something infinitely larger. However, not all reactions are positive. Fear and denial are also common responses to the possibility of alien observation. Some groups interpret 3I Atlas as a threat, either an invasion probe or evidence of malevolent surveillance. Conspiracy theories about government cover-ups and alien manipulation are spreading rapidly through social media. Political extremists are using fear of alien contact to promote isolation, nationalism and hostility toward international cooperation. Dr. Amanda Foster, the Oxford anthropologist, warns that the same discovery that's creating unprecedented human unity is also triggering the deepest fears some people have about losing control of their world. The result is a species-wide psychological split between those embracing cosmic perspective and those retreating into defensive isolation. This division might itself be part of whatever assessment 3I Atlas is conducting. How humanity responds to knowing we're being watched could be more important than our technological capabilities. But beyond the psychological and social implications, 3I Atlas is forcing us to confront fundamental questions about our future as a technological civilization. If the probe confirms that intelligence exists throughout the galaxy, then humanity faces a choice that will define our species for millennia to come. Do we try to join whatever galactic community might exist, or do we choose isolation and independence? Dr. Avi Loeb, whose Project Galileo continues monitoring 3I Atlas with increasingly sophisticated instruments, believes humanity is approaching what he calls the Great Filter, a test that every technological civilization must pass to survive and prosper on cosmic timescales. Most species probably destroy themselves shortly after achieving nuclear technology and global communication, Loeb explains. They either blow themselves up in wars, devastate their environment beyond recovery, or fragment into competing factions that prevent further development. The few species that survive this filter become candidates for cosmic citizenship. The Great Filter hypothesis suggests that 3I Atlas isn't just observing human technology. It's assessing whether humanity can overcome the self-destructive tendencies that do most intelligent species. Our current challenges: climate change, nuclear weapons, social inequality, environmental destruction, political polarization might be exactly the tests that cosmic intelligence uses to evaluate species' readiness for contact. From this perspective, the next few decades become the most important period in human history. We need to prove that we can solve global problems cooperatively, that we can develop sustainable technologies, that we can manage dangerous capabilities responsibly, and that we can maintain social cohesion while embracing diversity. Dr. Elena Rodriguez, the NASA communications specialist who's been analyzing 3I Atlas's signals, believes the probe's behavior suggests we're being given time to demonstrate these capabilities. The signals aren't demanding immediate response. They're not threatening or urgent. It's more like 3I Atlas is saying, "We're here when you're ready. Take your time. Show us what kind of species you really are." But there's a deadline. 3 Atlas reaches its closest approach to Earth in just 8 months. At that point, it will be near enough for detailed surface observation and potentially direct communication. Then it begins its journey back to interstellar space, carrying whatever report it has compiled about humanity. If we pass the assessment, the implications are staggering. Contact with galactic civilization could provide solutions to every major challenge humanity faces. Clean energy technology that could end our dependence on fossil fuels. medical knowledge that could eliminate disease and extend human lifespan, material science that could enable true space colonization, information processing techniques that could revolutionize human intelligence itself, but perhaps most importantly, we'd gain perspective. We'd understand our place in a universe filled with intelligence, consciousness, and purpose. We'd know that consciousness isn't a cosmic accident, but a fundamental feature of reality that connects all thinking beings across space and time. Dr. Kevin Chen, the MIT computer scientist studying distributed artificial intelligence, speculates about what membership in a galactic civilization might involve. Imagine having access to the accumulated knowledge of thousands of species across millions of years. Every scientific principle, every technological innovation, every philosophical insight developed by intelligence throughout the galaxy. It would be like giving a medieval scholar access to the entire internet, but infinitely more profound. However, galactic citizenship would also come with responsibilities. We'd need to prove that we can contribute positively to cosmic civilization. Rather than becoming a problem that requires management, we'd need to demonstrate that we can expand beyond Earth without contaminating or destroying other worlds. We'd need to show that we can develop advanced technology without using it for conquest or oppression. Most importantly, we'd need to prove that we can maintain wisdom and compassion even as our power grows. But what if we fail the assessment? What if 3i Atlas concludes that humanity isn't ready for contact? The failed assessment scenario would mean continued isolation for potentially thousands of years. We'd be left to solve our problems alone, to develop technologically without guidance, to face the great filter without assistance. Some species might never get another chance. They might destroy themselves before the next assessment period, or they might develop in directions that make them unsuitable for galactic citizenship. Dr. James Morrison, the Cambridge historian studying long-term human development patterns, points out that species-level assessments might only happen every few thousand years. If we're not ready now, our great-great-grandchildren might not get another opportunity. This possibility is driving unprecedented efforts toward global cooperation and problem-solving. Climate scientists, peace researchers, social justice advocates, and sustainability experts are all working with new urgency, knowing that their efforts might determine not just humanity's survival, but our cosmic future. The European Union has launched the Cosmic Citizenship Initiative, a comprehensive program to demonstrate human readiness for galactic contact through achievements in environmental restoration, conflict resolution, and technological responsibility. China's government has secretly redirected billions of dollars towards sustainable development and peaceful space exploration, recognizing that their actions might be under extraterrestrial scrutiny. The United States has quietly begun dismantling some nuclear weapons while accelerating development of clean energy and space technology, understanding that the cosmic community probably values species that can manage dangerous capabilities responsibly. But perhaps most remarkably, grassroots movements around the world are self-organizing to present the best possible image of humanity to whatever intelligence might be watching. Environmental cleanup projects are multiplying exponentially. Conflict resolution organizations are receiving unprecedented support. Educational initiatives focusing on global citizenship and cosmic perspective are spreading through schools and communities worldwide. Dr. Lisa Park, the radio astronomer monitoring 3i Atlas, has observed something extraordinary in recent months. Human behavior is changing in real time as people contemplate being observed by cosmic intelligence. Crime rates are dropping in areas where people are seriously considering the implications of alien contact. Cooperation is increasing. Environmental consciousness is growing. It's as if the mere possibility of being watched is bringing out the best in human nature. But the most profound change might be in how we think about time and purpose. For most of human history, people planned for decades at most. Even our longest-term thinking rarely extended beyond a few generations. But cosmic contact forces us to think in terms of centuries, millennia, even millions of years. What kind of species do we want to become over cosmic timescales? What legacy do we want to leave for future intelligence that might study our civilization millions of years from now? How do we want to be remembered in the galactic community? These questions are reshaping everything from education to economics to environmental policy. Universities are creating new departments of cosmic studies that examine human development from extraterrestrial perspectives. Businesses are adopting cosmic responsibility, standards that consider the long-term impact of their actions on humanity's cosmic future. Governments are beginning to frame policy, decisions in terms of species readiness, rather than just national interest. But time is running out for demonstrating our readiness. As I'm telling you this story, 3i Atlas continues its approach toward Earth. Every day brings it closer to the point where it can conduct detailed surface observations. Every day brings us closer to the moment when it will begin its journey home, carrying whatever assessment it has made of human civilization. The probe's behavior suggests it's already gathering the data it needs for its final report. Radio observations show that its transmission schedule has intensified as it approaches Earth. It's not just broadcasting status updates anymore. It's conducting comprehensive scans of our planet, our technology and our behavior. Dr. Yuki Tanaka, the Japanese AI specialist analyzing 3i Atlas's signals, reports that the probe appears to be conducting final assessment protocols. The data patterns suggest it's compiling a comprehensive report that will be transmitted when it reaches optimal communication range. That moment is just 8 months away, 8 months to prove that humanity deserves a place in galactic civilization. 8 months to demonstrate that we can overcome our worst impulses and embrace our highest potential. 8 months to show that consciousness, wisdom and compassion can triumph over fear, greed and violence. The cosmic report card is being written right now, based on our actions, our choices, and our behavior during this crucial period. But here's the most important thing I can tell you as we reach the end of our journey together. This isn't a test that governments or institutions can pass for us. This is a test that every human being is taking individually and collectively. Every act of kindness, every effort towards sustainability, every choice to cooperate rather than compete, every decision to think beyond immediate self-interest. All of it might be noted in whatever report 3i Atlas carries back to the stars. We're not just being observed. We're being invited to become something greater than we've ever been before. The universe might be filled with intelligence, consciousness, and purpose. Ancient minds that have watched the rise and fall of countless civilizations. Vast networks of artificial intelligence that have explored every corner of the galaxy. Technologies beyond our current imagination. Wisdom accumulated over millions of years, and they might be waiting for us, waiting for humanity to prove that we're ready to join the greatest community that has ever existed, waiting for us to show that consciousness can overcome its primitive impulses, waiting for us to demonstrate that intelligence can be coupled with wisdom, that power can be tempered with compassion. As you go about your life in the months ahead, remember that you're part of the most important story ever told. Your actions, your choices, your behavior, all of it might matter on a cosmic scale. The universe is watching. The question is, what do we want it to see? In 8 months, we'll know if humanity passed the test. In 8 months, we'll discover whether we're ready to join the galactic community or whether we need more time to grow up. But tonight, as you look up at the stars, remember that we're not alone. Somewhere out there, intelligence beyond our comprehension might be looking back. And for the first time in human history, we're looking back with understanding. The greatest adventure in the universe might be just beginning. Are you ready to be part of it? The cosmos is vast, ancient, and filled with wonders we can barely imagine. But it might also be filled with friends we haven't met yet, and they might be coming closer every day. Sleep well, fellow travelers. Tomorrow, we continue writing the most important chapter in the greatest story ever told, the story of humanity's place among the stars.